I'm Mike Letchin. I'm one of the sales engineers for Nexenta. I also focus a lot on the virtualization space, and we've been doing quite a bit of work with Cisco with the UCS chassis. So we're going to kind of go a little bit on why it matters, what it is, and then move into with UCS and Cisco. No, I took the other one off. Their mic, they already have. So I didn't sound like Daffy Duck the whole time. So we're going to kind of go into first application-centric storage. And you have probably not heard that term used quite a bit. It's something that's starting to kind of trend a little bit more, and you'll understand why as we get through this. So really, the app is where everything comes down to it. The storage, we've been using storage forever, but how does it really matter? How are we using it? So you've got a lot of different aspects of it. You've got CIOs that are looking at storage going, the cost is horrible, it's costing me a fortune, how do I do this for less? Things like, I don't really care about those speeds and feeds, how am I gonna actually get what I need for my business model to work? That's where they care about the app. Then you move into the app owner, their concern is all about performance, it's availability, a little bit of performance, and eventually what the end user gets. But if that's that app owner, all they really care about is how am I gonna make this work? That's my baby, how do I make it work the way I need to? Then you get the infrastructure team. The guys that are building out this environment going, yeah, the app owner can want this all they want, but I have this much budget and need this much storage to do it the way they want. How do I make those two fit? How do I combine them and actually get each of my applications, each of my models, whether it be for email, whether it be for virtual desktops, whether it's servers, whatever it is, how do I make that all work with storage? The way to get to that is using application-centric storage. Realistically, right now, if you were to just say, I'm going to put an array out, that generic storage, what you're using every day, just general purpose, is dead. There's no way that you can make a single array that is going to work for every environment you have. If you have the same array that you're looking at for your desktops, the same array you're looking at for your Exchange environment, could you have one physical array? Potentially. But it's got to be carved out specific for the application. And the application is really what we care about at that point. That load should change depending on how you're using it. If it's, like I said, it's an email workload, I want to make sure that I've got a lot of ability to get those speeds and feeds in and out. Desktops, it's a lot about write IO. It's how much I can write to it and get the user data pushed to it. I need some read. If I'm using a clone basis, that I can read that data off and see it. But that's not the focus. So it's a different set of storage depending on how I'm using it. As your environment grows, as your environment changes, your storage should change with it. When you buy a can in one box, you can't do that. It does things like the virtual first mentality. How many people in here are pretty much 90% virtualized by this point? It's just about everyone in here is virtualized for their environment. And your first step, if somebody wants a new server, is it virtual first and then you'll think about whether you buy a physical server? If there's a real purpose? Does anyone just go buy servers right now just because I need a new database, I have to go buy a server? Nobody? Yeah, I didn't think so. I don't remember the last time I bought a server for one workload. To be able to do that though, those virtual servers, you guys all know the storage on the back end makes a huge difference. How does that application impact? What are you doing with it? Then there's that availability that comes into play. That app owner, their big concern was availability. Performance coming up right after it. That availability, when you've got it in a virtual environment, you're able to flex, you get a lot more out of it. So to get application-centric storage, there's kind of a process you've got to get through to get there. And when you're following this process, you can get a lot of different aspects of what your model should look like. The first thing you're going to look at is what does that application need? It's Exchange. When you build out an email environment for Exchange, the first thing an infrastructure guy is going to do is most likely go to Microsoft, pull down their spreadsheet that has the sizer, put in it's this many users, it's this big a workload. Maybe you're looking at the same spreadsheet. We do things like when we put Metis into play to look at that, so you guys can see that. When we've got different environments that you can search things and find it and hand it back to you and what you need. Maybe it's for VDI, I'm going to look at the same thing. How many desktops? How much do I need to perform? Where do I want to put them? All those scenarios, that's the first step. I move from there into where am I putting it? Figure out what I have in my infrastructure. How do I make that grow? Is my infrastructure flexible? Am I using just VMware? Am I using just KVM? What am I using? And since I'm not putting it on physical anymore, everything's going on a virtual environment, why shouldn't I utilize that same availability, the same resiliency for my storage as I'm using for my servers? Then you get to play with things like VSA. When you put a virtual storage appliance in, now you're able to take that host and your storage, combine them, and be able to tweak them and tune them as needed. You can get more performance out of it, you can get less performance, you can give it more SSD, you can give it less depending on where you need to put it, which host you're putting it on, where you're moving things to. There's a lot of reasons you want to do that. You're looking at that cost per user, cost per server. Your cost is going to drop now. A lot of times that's what your CIO wanted. The first thing they cared about for your app was, how do I fit it in my budget? How do I keep my CFO happy by dropping that cost? The high IOPS, when I've got burst, anything that I need that's going to change my environment dramatically, that's where I need to look at how can I take this virtual appliance, tune it to get where I need with my storage. Is it high IOP? Well, maybe if I'm looking at high IOP, I need to grab the SSD. You guys are used to it with your storage environment in general. If you put in a ZFS environment, you know it's going to use the hybrid storage pools. It's going to move data as needed. There's no reason you can't do that in the virtual space as well. Give it a couple more SSDs in your host, yank them, and give it back to everybody. You've got a lot of flexibility there. Network traffic. If you're putting an Exchange environment in, the biggest problem people complain about when you put an email environment in is my email's not coming to me quick enough. I'm sure everyone has had the person who sends you an email and then they pick up the phone and call you right away and go, hey, did you get my email? It happens all the time, but it's because they're so used to having environments that the network traffic has stopped email from flowing as quick as it needs to get to you. When you put your storage right beside your servers in that same environment, and we'll get to this a little bit with UCS on how that connects and how we're able to get that flow across, you can speed that environment up dramatically. Things like uniform IOPS. If you've got 3-4 database servers, do you want to talk to one DBA that says, hey, my environment's working great? Then you talk to your other DBA, oh, it's really slow. Next DBA is, oh, well, it's okay sometimes, other times it's not. If you have consistency, you can always go back to them and support your end user, your application owner, whoever that customer is, to be able to get them what they need. So playing that into how you're going to do that with Cisco. And this was a design we worked with Cisco to develop on how to use VSA and really deploy it out for, whether it's for desktops, whether you're looking at for servers, whatever you're looking at for that workload. You've basically got all your networking up top and your fabric interconnects. And when it gets into UCS, this will even make more sense. Just kind of give you a quick look at it. But then your standard storage is sitting on the back end, and all these little VSAs, each one of them could be for a different application. It could be combined for multiples. It gives you the flexibility to make your environment run the way you need it to in that virtual space. So now where you were looking before at how do I build my SAN? Now you're looking at my application and saying, how do I take an application, run it through a process, produce a SAN, take stuff I already have, produce the SAN I need, and give it back to the end user with the right amount, the right quantity, the right performance. You were all looking at this slide like you were completely perplexed. It's servers and switches, guys. You're really going to have a hard time up here if they're looking at that slide tough. The next thing is whether you want to do, you get that application benchmarking. After that, I want to be able to make sure it's doing what I want to do. When you have things in a virtual environment, when you're doing things that are application-based, you started out being application-based, you move through your whole process, and the first thought in your mind is, what do I do with my application? What do I do with my application? What do I do with it? When I get to the end, I need to make sure that worked. So when you're doing things like building out that SAN specific for your application, you now have the ability to come back at it and say, okay, this makes sense. Now let's tweak it, let's tune it. Am I getting that uniform IOP that I needed across the board? Am I getting the same IO for all of my VSAs, for all of my database servers? Is email traffic getting across the way it should? Because now I can actually look at that network workload from a VSA within the array. Use the tools you have. You have vCenter sitting in place already. You've already got potentially things like vCenter Operations Manager that you can see that data already flow. Why not take it and use it for your storage and get the same capability? Normally, you've got 6 other things you're looking at. Stop looking at multiple things and have a single console for the same thing you're doing. Did that completely throw everyone off, or everyone good on why we're looking at the application? You've already been confused on the one slide. I got that. He'll clear that up.
I'm Bart-Jan Menkveld. I'm a system engineer for Cisco in the Netherlands. I usually spend my days in designing and building UCS and Nexus solutions for customers. And now I'm here telling you a bit about our unified computing system. So, how's my presentation going? Great. Good. Before we start, who of you has cats or dogs? Yeah, I do. This is a Poes, cat in Dutch. And she's my pet. She likes to help me with my PowerPoints. Usually not very useful. I'm still trying to figure out if meow means great slide or skip it. But hey, do you remember when your pets were little? You have to potty train them, feed them, keep telling them, cats, no, the curtains are not for climbing. Therefore, keeping out the light, not for climbing. It takes a lot of time. Compare it to a farmer. He has thousands of cows. What does he have? He has a farmer, you have a farmer's wife, couple of farmhands, 1,000 cows, no problem. That one cat, you know how many times it costs me and my wife to train it? A lot. So why are we using and looking at our servers like we are looking at pets? They're not pets, they're cattle. We buy them to do work for us. Keep that in mind in the rest of the presentation. So when we are at Cisco, most of people say, oh, routers, switches, welcome. Oh, servers, do you do servers? Well, I had to put this marketing slide in. Yes, we do servers. We're actually good at it. Gartners say, well, you're number 3 in our Magic Quadrant right now in 4 years' time. So I think quite an achievement for a new player in town. What I'm going to talk about, the unified computing system. 3 topics. The general architecture and network I/O, stateless computing and service profile, and the power of our API. We divide in 2 things, the core capacity and our scaling. Well, first go a bit legacy. We buy a blade center, we put some blades in it, we put management inside. Well, if we're finished, blade center is full, hey, let's get another one. New management, new switching, new storage, goes on. So management, and every separate piece is a management point. People have to look at it, people have to configure it, people have to change things. Well, when we started to design our new infrastructure, well, maybe that's not the best idea. What we did, we put management in place, on a central place, and well, everything is there. Then we put a small chassis, 8 blades, nothing really too spectacular. Okay, let's go. Oh, we need more blades, more blades, more blades. 160 blades. Now the magic happens. 1 GUI, 1 touch point. Only one place to go for your updates. Only one place to go for your BIOS settings or your network settings. Not all different touch points, just one. Keep the management to a bare minimum. Just like the cattle. Just move them to your paddock. Don't potty train them. How do we do that? We start with the fabric interconnect. This is the heart of our entire blade system. Our chassis is just metal to prevent blades from falling down on the floor. We have a user interface used by an API. The API we use for our GUI is the same as you can use in your own programming. Below that, we have a fabric extender. It looks a bit like a switch, but it isn't. It's just a multiplexer for the cable between the extender and the fabric interconnect. No logic, no intelligence, we keep it all on top. Below the fabric extender, we can place a chassis or rack servers. We really don't mind. We manage them the same, we use them the same. And bandwidth, well, you start with 10 gigs. Everything is 10 gig Ethernet in the UCS. And if you need more, well, you just add more, up to 160 gig per chassis. Our philosophy is you wire for performance, not for functionality. So all the functionality is there in the same wire. Storage, compute, management, data networking, it doesn't matter. We virtualize that, we only wire for performance. And that makes really neat, clean racks with, well, not too much cables. So 160 servers for the large customers, maybe that's not enough. So we build a management layer on top of it. Of course, the manager of the managers, we can go to 10,000. If that's not enough, please call me. We can figure something out because I really would like to know you. Because we're a bit late, I'm not going to show you this video. Please come by to the stand. I'm going to show you the great video of how this all works in practice. A lot of the frustration I had before I joined Cisco with competitors, if I bought a new rack of servers, I had to go to every server and I had to update the BIOS, put the configuration there. It took me a couple of days just to get the server I got in the rack, in the box, before I could actually use it. We have recorded the demo, 25 minutes, 30.7 seconds. It's all it takes to get a server in the box, up and running, starting the first VM. It's a really nice video. I'd love to show it later. Good, back to the servers. I've showed a blade server, basically it's the same for rack mounts. Two things. The top part is common. Everybody uses Intel CPUs, memory, disks. That's not where a differentiator for a server lies. Everybody uses them, everybody builds it. The bottom part, that's where the magic is. We have built our own NICs. Of course, our legacy is networking, so of course we're going to start there. Up to 80 gigs per blade. If you have a dual width blade, it can be 160, but 80 is enough for most. Everything there is centrally configured. How many NICs do you want? Be configured centrally. How many storage adapters do you need? Centrally configured. So all the state of the machine is configured there. That's my second point. Stateless computing and service profiles. Who has a smartphone? Android, iPhone. When you buy a new iPhone, you do two things. You place your SIM card in there, and you log in with your Apple ID. And then, hey, I have my contacts, my apps that I can download again. So all the state of your phone is not in the phone anymore. It's in your smart card, in your SIM card, and in your Apple ID. We copied that principle for our service profiles of our servers. All the logic behind the server is not anymore in the hardware. The hardware is fully stateless. We configure it in a central abstraction of that server. So let's take a quick trip to the virtual world. We build a machine, and well, this is a really good web server. So what are you going to do if you need 10 more? You're going to build 20 more really good web servers? No, you're just going to clone it. So why, if we have hardware, and I really like this BIOS settings, and I really like this kind of NICs, if we buy a new server, why do we do it all again? You can just clone our representation, and we have a new server. This is a short summary of what is in that server profile. And, well, I created it, I cloned it 4 times. What do I do? I take some hardware. And now I have 2 running servers. Again, all the logic is in the configuration. You push it out to hardware. If hardware fails, it doesn't matter. Same as a farmer. If some of his cattle dies, yeah, of course it costs money, but you have no personal attachment to it. You just buy new cows. So, in the end, we have shown you a great way of how we build servers, but the real power lies in our API. Because in the end, we have a lot of hardware, and we don't want to think about it. We want to know if our provisioning system says your VMware cluster is running full. Okay, power up new blades. Find them, configure them. That's why we created the API in our UCS solution, which is totally open. We don't hide anything which we can use and you can't. Actually, our own GUI uses the same API as you all can use. So this makes integration perfect with every provisioning system you can imagine. Of course, open standards, we have Python APIs, XML, and we also use PowerShell. This is a short introduction to our unified computing system.